Lesson 9, the chain rule. Now, delta y on delta x is the change in y of the change in x. That can be expressed as the change in y of the change in u times the change in u of the change in x. Because this is just like a fraction. But these could cancel out and you're back to delta y and delta x. We take the limits to both sides and we get the limit as delta x goes towards 0 of delta y on delta x is equal to the limit as delta u goes towards 0 of delta y on delta u, multiplied by the limit as delta x goes towards 0 of delta u over delta x. Of course, we know that this can be written as dy dx, and this can be written as dy du, and this can be written as du dx. And that's the simple chain rule, a very important rule. Now let's see an application of this. So we take y equals 3x plus 2 all squared. Now I'm going to expand the brackets and write it as 9x squared plus, it becomes twice the product, 12x plus 4. Now differentiating as we did before, and dy dx is equal to 18x plus 12, and that equals 6 outside of 3x plus 2. Now that's without using the chain rule. Now using the chain rule, we'll say let u equal 3x plus 2. That means that y must be equal to u squared. So du dx is equal to 3 and dy du is equal to 2u. So using the chain rule, dy dx must be equal to dy du, which is 2u, times du dx, which is 3, which is 6u. And now replacing the u with 3x plus 2, we get 6 outside of 3x plus 2. Now you can see in this case, we didn't really need to use a chain rule. We could use this, but in the next example, I'll show you a very good application of the chain rule. Now, in this case here, you can see it'd be impossible to work it out without the chain rule. So let's have a look what we do. First up, I'll write this in index form. I'll write this as 3x plus 2 to the negative 1. Now I'm going to let u this time equal 3x plus 2. So y must equal u to the negative 1. Du dx, you can see is 3, and dy du, just careful with the sign with this one, it's minus u, and we subtract 1, you get minus 2. Now remember, the chain rule is dy dx equals dy du times du dx. Just remember, the easy way to check this is that these must cancel out and you get back to dy dx. And dy du is minus u to the minus 2, and du dx is 3. Now tidying this all up, we're going to have minus 3 over u squared, but we must replace the u with the 3x plus 2, so that's 3x plus 2 all squared. Alright, just have a go at this one yourself. Let's pause the video. Okay, so you should have written this in index form as 3x plus 2 to the half. Again, we'll let u equals 3x plus 2. So y equals u to the half. Du dx equals 3. dy du equals, now the half comes down the front, a half u to the, take one away, minus a half. And dy dx equals dy du times du dx. So dy dx is equal to dy du, which is 1/2 u to the negative a half multiplied by 3, which is 3 on 2, u to minus a half, which equals 3 over 2 root u. And don't forget to replace the u with the 3x plus 2, and that's equal to 3 over 2 root 3x plus 2. Okay, now in the next exercise, I'll show you an even faster way to do this. But this chain rule is very, very important because later on, when we start to do the applications of calculus, it's a very, very important rule to remember.